All right, hopefully this works, but I am going to make a recording of the lesson that we went over in class today for you to review if you so choose. What I'm going to be working on is a handful of content that is within our fourth chapter here, Exploratory Data Analysis, which is going to be the lesson plan that contains all of the code that we want you to learn, as well as some assignment questions that are embedded, and that's actually part of your assignment for this week. But because I can't go over all of this, I'm going to essentially just create my own R Markdown to demo some of the most common heavy hitter functions that we're going to be using time and time again in this class. So if you want to follow along with me or not is up to you, but the very first thing that we're going to do is locate that R project folder that we created in the first week of class. So for me, I have that stored actually in a teaching subfolder, this FA25 ESS 523A, and I'm going to click that R cube. So the .R project extension is going to open me up in RStudio in my R project. And you can confirm that we're in the proper location, that being the R project for this class, by noting here, if you click that cube, it kind of brings you to what I like to call base camp, but the main area of your R project, and sure enough, we're in the right place where we did our first R Markdown. We created that setup script that contains the packages that we want to load each time we open up RStudio. And I'm going to create a new R Markdown. I'm going to do that by clicking on the File button, New File, R Markdown. I'm going to call this, for consistency with the chapter, I'm going to call it Exploratory Data Analysis. And I'm going to set the default output to HTML. When we work in this class, I suggest getting used to rendering via HTML because later on in the class we're going to be developing interactive plots and figures that you can only really interact with in an HTML document. But if you're uncomfortable with that, feel free to also render to Word. It really doesn't matter for these first few lessons, but we do advise you against rendering to PDF. But once I've got all of these settings figured out, I'm going to click OK. It's going to automatically open this new R Markdown. And I'm going to get rid of all of this example code that it always generates when you create R Markdowns in this way. But I am going to keep that knitr opts chunk code, which is essentially telling my R Markdown how I want all of the chunks to render. In this case, we want to make sure echo is set to true so that when you submit assignments, we're able to actually see the code that is used to generate whatever outputs we're asking for. So I'm going to just at the top here put Katie's demo. Once again, you don't really need to follow along with this unless you'd like to. But some of the things I'm going to go over are select, mutate, filter, group by, summarize, and how to use the pipe. But the very first thing we want to do in working in R, as you should know by now, is we want to load in all of our packages. Because we have that setup script that contains that library function calling each of the packages we want to source that code. So we source it by using the source function, and then you provide it the file that contains the code you want to run. So I'm going to run it. And now I have the tidyverse, Palmer Penguins, and I think R Markdown installed. Or pardon me, not installed. Well, it is installed, but now also loaded into our environment. This week we're working with the Palmer Penguins data again. So the other first thing that you want to do is load that data in. To load data from a package, you run the data function, and then you write out penguins in quotes, which you can see those are now loaded in our environment. And the first function I want us to learn how to use together is the mutate function, which is how you can add new columns to a data frame. So this is the tidyverse syntax to create new columns. First, I want to create a new object to store this new data frame in, and I'm going to call it penguins mod for modification of penguins. And so to add a new column, we're going to first use the function mutate. Within the mutate, the first thing you want to provide is that .data, meaning what data frame do you want to add a column to. For us, we want to add a column to our penguins data frame. And then after that comma is when you start adding the columns that you want. So for the purposes of this demonstration, let's add a new column called animal. Well, in our penguins data, all of them are penguins, so I'm just going to fill all of them with penguins. When you provided a single character string like this, it'll automatically fill each row with whatever that character string is. So I'm going to run this code and show you what that looks like. But our new penguins mod object is going to look like our penguins, but with a new column, which you can tell there's one extra column here, where each of our rows or penguin observations contains that penguins. But that's not very, that's great, but there's plenty of other things you can do with mutate, one of which you can create multiple columns at once. So let's pretend we hate the units millimeters, and we want all of our units to actually be in centimeters. To do that, once again, we're going to create a new column name called bill length centimeters. And what we want that new column to be filled with is what exists in our current column, bill length millimeters, but we divide it by 10. We'll do the same thing for bill depth. And then the other unit, measurement flipper length. Oop, I accidentally put centimeters here. So now that we have a column being used to fill another column, it will use the information row-wise contained within that column to fill in our flipper length in centimeters. So let's go ahead and run this and see what the output looks like. Our penguins mod. So for example, that bill length in millimeters, it's 39.1. But in our new column, bill length centimeters, we've divided that value by 10. And we do that row-wise across our whole data set for each of those new columns. Well, now that we've created new columns where we're using centimeters, we don't really need the millimeters columns anymore. And so we can remove those. So one way that you can remove or add new columns, remove or select certain columns is through the use of select. So we're going to continue to modify this penguins mod. We're going to start with that object. We're going to just overwrite our penguins mod. We want to select from our previous version of penguins mod. And then after providing it the data frame we want to manipulate, this is when we start selecting or disselecting. In this case, we want to remove 3 columns. So to remove 3 columns at once, we actually just use the minus sign and the concatenate function together, meaning we don't want what's contained within this, this vector of column names. So in here, we're going to just fill it with the columns we don't want. Bill length millimeters, we no longer want bill depth millimeters, and we don't want flipper length millimeters. So when I go to run this, you'll see now that those previous measurements no longer show up. Now you can do the reverse of that, selecting others. I'm going to call it penguins mod select just for the purposes of demonstration. Let's say we don't care about any of that stuff, and the only columns we care about are the sex, species, and island. So to do that, we basically do the exact same thing that we performed for the unselection, but we removed that negative sign to say all I want is actually these columns. And so you have to explicitly list each and every one you want. So depending on how wide your data is, like depending on how many columns, sometimes it's easier to remove some than to select a whole bunch, right? But just for the sake of showing, our penguins mod select now has just got those 3 columns that we cared about in that demonstration. So the next big data science skill is to filter or subset our data frame into something smaller. For example, here, let's say we only actually care about the Adelie species of penguins, and we want to get rid of any non-Adelie species from our data frame. So to do that, we're going to use the filter function. I'm going to call this new object of just Adelie species, Adelie, and we're going to use the filter function. Once again, we have to tell it which object we want modified. For us, let's do our penguins mod. And then here's where we give it how we want to filter. So we want our species column to be filtered to contain only the Adelie species. Now take note here of the double equal signs. This is really important. When you do statements like this that are either true or false, meaning does species equal Adelie, yes or no, like those binary operators, you always have to use the double equal signs. If you gave it just one equal sign, R won't know that you're trying to do that logical statement. So just always remember when you're filtering or wanting something to be compared against itself, something else rather, always use that double equal sign. And sure enough, this new object Adelie contains only Adelie's species in the data frame. So it went down from 344 rows or observations to 152 observations. Now, all of this code that we've performed, where we created a new column containing our information in centimeters, we removed the old millimeters columns, and then we filtered to just Adelie's species, we can actually perform all of those steps in a single chunk of code, and that's through the use of piping. Piping is the best friend of all data scientists. It makes it really easy to understand what's going on when you have multiple steps like that, because they're all contained in essentially a single chunk of code, as well as a single object that you're able to look at. So to use the pipe, I like to think of it as, anytime you use one, you think of it as and then. So in the cases of what we want to do to create this Adelie's object, we want to start with our penguins data frame, and then we want to add our centimeter columns, and then we want to remove our millimeter columns, and then we want to filter to just the Adelie's species. So to get Adelie looking the exact same as the one there in my line 44, but through piping, we're going to do just that. So we start off with our penguins data frame, and then we want to create new columns, just noticed this got filled with the wrong one. The length. Oh, and we added that extra silly column, but animal equals penguin. So we've added these new columns to our data set, and then we want to remove our former measurement columns that were in millimeters. And then, lastly, we want to filter the whole data set so that the only species remaining are the Adelie species. And sure enough, our Adelie and our Adelie piped objects look the same. The one difference being we created one through piping and the other through more standard code. So the last grouping of functions I want to highlight is the use of group by and summarize. Let's say that we are interested in exploring Adelie species across islands. For example, which island has the bigger flippers or something like that. So the way we can do that in R is through the use of group by and summarize. The first thing, actually let me back up one bit. So something that you may have noticed when I did this piping is that unlike in my previous steps where I had to explicitly identify what object I was performing that function on, I got rid of that here. And the reason is because of that pipe. So all of these tidyverse functions know automatically to perform that function on whatever happens above it, right? So for this example, we have our penguins data set. Mutate knows now to perform or add these columns to the penguins object. Then you go further down to the next pipe. This select knows to remove these columns from whatever happened above it, meaning the data set that's been produced by this chunk of code. And then just to tighten it up here, this pipe does the same thing, where when we are filtering by species, it knows to filter across the data set produced from all of the previous steps before it. Okay, just wanted to take note of that. It's very common to want to add the object name in there in a pipe, but you'd never want to do that. It'll make R very angry at you. So just note, if you're going to pipe, you don't need to store the object name in the previous functions that you want to perform it on. Okay, so back to summarizing. I had an imaginary research question. What was it? It was, what island has the larger flipper lengths for our Adelie species subset? So to do that, I'm going to do Adelie summary object, and that Adelie summary object is going to be performed on my Adelie piped data frame. So we start with our Adelie piped, and then we want to group by. So group by essentially creates categories in which you want the data to be summarized. In our research question, we said we want to assess by island. So you'll put island in the group by. After which we pipe that into the summarize function. And summarize is in some ways a lot like mutate as far as its syntax. So our summarize, we are going to say the mean flipper length is going to be the column it's contained within. And we want to fill that with the mean flipper length for each one of the penguins grouped by island. And remember, we always want to set our NARM to true in case there are any penguins with missing flipper lengths so that the code doesn't break. And let's give it a run. When we look at our Adeli summary now, we have for each of our islands a single row and its associated mean flipper length of those penguins. So it looks a little different than our original data frame, right? Now, we did just a single summarize here, but what if we wanted to do not just the mean, but the max flipper length for each of our islands? We can do that by just adding a comma and then moving on to another column, much like mutate. So I'm going to call it max flipper length, and that's going to equal the max of our flipper length, centimeters, RM equals true. When I run this, it's going now to provide two different summaries, statistics for each of our islands. So looking at the data here, you can tell that the Adeli penguins on the Torgerson Island are the biggest. Let's say we not only care about island grouping, but we also are interested in the difference between sexes. So much like how summarize can handle multiple things you want to summarize, group by can also handle multiple things you want to group by. So now if we just add another column, which is sex, I believe, and perform the same summarization, what it's going to do now is aggregate all of our penguins by their island and sex. So whatever combinations of those exist in our data set, it will perform the mean and the max on them. So when we look at it now, you'll see our data frame is a bit longer, and that's because now for every island we have both all of the sexes associated with penguins on that island, but with the same information contained. So just out of curiosity here, we can tell that males are typically larger than females across the islands, and that the Torgerson contains still the biggest both males and females. So that's all I want to share with you in this video, but I just want to stress once again that all of the code I just showed you is contained within this 4 exploratory data analysis lesson plan as well, and we highly suggest you go through this entire chapter to get a better understanding of how not only those functions work, but how other functions that can be used within them work as well.